So yesterday we spent a lot of time finding inverses, and today we're going to spend a lot of time looking at original functions and deciding if there is an inverse function. So, and also this new thing we're going to do where we have a table or a graph, and instead of evaluating the function at a value, we're going to evaluate the inverse at a value. So you have to think about it a little differently. And so we have this table of values, and the first question asks us to find f inverse of -5. And so it is not the same as asking us to find f of -5, because if it did, we couldn't do that because there isn't a -5. So what do you think it's asking you to find? So if you were looking at this table, what do you think the answer would be? Yes, -2. So it's telling you to figure out what x value gives you -5. Because the inverse x and y are switched. And so the x value that gives you -5 is -2. Right. Same thing on B, is that f inverse of 44 is saying f of what gives you 44. And that's just going to be 6. And then C takes us to something that's a little bit of an issue. And so, plus 2. If we're supposed to evaluate the inverse function when x is -1. So what would you guys say? You can't, because there's two values. And whenever you have when you have a function, you put one thing in, you get one thing out. In this case, you would get two things out. And that's a problem. And so that is because this function is not invertible. And that means that it doesn't have an inverse function. Bless you. It has an inverse relation. It doesn't have an inverse function. All right, so let's talk about invertible functions. And get used to this first statement because you were going to write it quite a bit in the next couple days. So a function f is invertible or has an inverse function if each output value of f is mapped from a unique input value. All right, so basically it's saying only one input will give you that output, and that's a problem for -1. Because two different inputs give you that output. So it doesn't mean it's not a function. It is a function. It's just not an invertible function. Sometimes invertible functions are called one-to-one functions. Do you remember what you used in Algebra 2 to determine if a function had an inverse function? The horizontal line test. So the vertical line test tests to see if the graph is a function. The horizontal line test is basically checking to see if it's an invertible function. They didn't use that terminology, but that is what you were doing basically. All right, and then bullet number 2 is something that comes in handy whenever you have a table and you're trying to determine if it's invertible. So a continuous function will only be invertible if it is strictly increasing or strictly decreasing. Right. So anytime a function changes from increasing to decreasing or changes from, I said it backwards, this was decreasing to increasing last year, or increasing to decreasing, it's not going to pass the horizontal line test, which means it's not invertible. Now, when we're given reasons for a function to not be invertible, you cannot use horizontal line test as your reason. You can use it in your brain that you're checking using it, but you can't write it. So when you're writing a reason, it has to go back to the definition of a function and the definition of an invertible function. All right, here we go. So we're going to look at these graphs, and we're going to determine if the functions are invertible, and then we're going to give a reason based on the definition of a function and the graph. All right, what do you guys think about A? Is A invertible? Yeah. So every single output comes from a unique input. Your output is never repeated. And so we would say, we're going to write this very precisely, F is invertible because each output value of F is mapped from a unique input value. Great. What do you think about B? No. So whenever it's not invertible, it's a good idea to say not invertible and give the reason, but also give an example of why. So we would say that in this case, G is not invertible because each output value of G is not mapped from a unique input value. Okay. And there's like technically an infinite number of examples we could use. These two cross at an exact point. These two also do. So you can just pick one of those or one of those pairs. I'm going to go ahead and just do f of 5 is equal to 0 and f of 8 is equal to 0. All right, so you guys try C on your own, please. All right, so on the next example, we're going to do some examples using compositions and inverses. But first, I forgot to do this last period. What if you did the composition of the inverse of G of 2? Can you figure that out without even plugging anything in? What do you think it would be? What does the inverse do to the original function? It just undoes it, and so that should just be 2. If you, same thing like if you did h of h inverse of 0. It should just be 0. So the inverse will undo what the original function did and vice versa. All right, so now we're going to do, that doesn't happen when it's two different functions though. So like the inverse of g is not going to undo what h does. They're totally unrelated. Oh, and I do have a typo here. So selected values of, this should be strictly decreasing function g, because if you look at g, those y values just get smaller and smaller each. That's just a typo. And strictly increasing function h of x are given. And so why do you think I told you that? They were strictly increasing or strictly decreasing? That makes them invertible, right? Good. All right, because we don't know, like on a table, we don't really know what's happening in between -2 and -1. There could be like a little max or min. So we need to know that when it's a table. Okay, so here we go. We're going to always start on the inside. So we're going to do g inverse of h of -1. H of -1 is just normal. Find the value of h when x is -1. So that's just going to be -7. And then g inverse of -7 is the new thing we've been doing today, which is find what x value is going to make g -7. And so the answer to that would be 3. Did I do that wrong? Maybe I did it wrong on my last one. Oh no, sorry, I'm looking at the wrong. Is that what you got? Does that make sense? Okay, I definitely did it wrong last period. All right, we got that on video. Sweet. All right, let's look at B. We're going to do h inverse of h inverse of g of 2. All right, so we're going to start with g of 2. G of 2 is -3. And then we want to know what value of x is going to make h -3. What do y'all think? 1. Good job. All right, so you guys try C on your own, please. What did you guys get? 0? Start. Bless you. This one's a little trickier. On some of the ones we were given, there wasn't an x of -7, so it was obvious you were going to do something different. There is a g of 1, but that's not what we want. We want what x value makes g 1, which is 0. All right, are y'all okay? Because I see scrunchy faces. So just remember, whenever it's g... All right, so whenever it's g inverse, it's not saying what's the value of g when x is 1. It's saying what x makes g 1, and that's going to be a 0. Okay. The other thing we're going to do today is look at a graph of a function and tell answers like what is the maximum of the inverse, or what is the minimum of the inverse, or the domain and range of the inverse. So just remember that when you have the inverse function, the x and y's are switched. And so on this first one, it also means the domain and range are switched. So this first one, I am going to graph the inverse just because we haven't done that yet. The other ones, I'm going to see if we can just figure out the answers without doing the graph. Before I do the graph, What would you guys say the domain of K is? Yes, -4 to 11. So the smallest x value graphed is -4. It goes all the way to 11. Would you guys say K is invertible?
Yes.
Yes. All right, what about the range?
-3
Yes, bless you. All right, now I'm going to do the graph. And so what I'm going to do to graph it is just at these turning points, I'm just going to switch the x and y. And so this first one is the point -4, -3. So when I graph the inverse, I'm going to graph -3, -4, which is there. All right, this point is 4, -1. So when I graph the inverse, it's going to be -1, 4. Okay, and then 6, 4 for the inverse would be 4, 6. And we have to get a little creative on the last point. 11, 6 is going to be graphed at 6, 11, which we're going to say is way up there. And in Algebra 2, you might have learned that the inverse is the reflection over the line y equals x. So this dashed line with a slope of 1, if I reflected the black line over that, it would give you the blue line. That happens with every inverse.
Is it just between those two? Or
Every inverse is like that, reflection over the line y equals x. We drew it. Okay, and so let's look at this. We're going to answer questions about K, and we're going to answer questions about K inverse. So what is the minimum value of K? So the lowest y value in K, -3. And you can look at the range. The lowest y value is going to be the left number of the range. What about the minimum or the lowest y value of K inverse? -4. Can you look at what we did here and get that minimum y value from it? Where is that? Yeah, it's the minimum of the domain. So anytime, like, we don't have to draw the inverse if you don't want to. Like the next one, I'm not going to. If you want to find the minimum value, it's going to be of the inverse is going to be the smallest number in the domain because the domain and range will be switched. All right, let's do, we're going to find K inverse of 6. We can do that two ways. Since we did the graph, we can look at, let's label it just to help us. This one we graphed is K inverse. If I have the graph of the inverse and I want to find K inverse of 6, I can go to, well, it's kind of hard on this one. I can go to 6. This is graphed up at 11. If I don't have the inverse, I just have the original graph, I can go to where y is 6 and find what x value gives you that. So either way. All right, so K inverse of 4, I can go to where y is 4, go to the original K graph. That's just going to be 6. Or if you wanted to, we have this inverse graphed. We could go to where x is 4, the y is 6. So it's always going to work out the same way. All right, and then C, we're going to find the domain and range of the inverse function. We can get that from this graph if you wanted to, or we can just switch the domain and range of K. So if I want to find the domain of K inverse, it's just the range of K. And if I want to find the range of K inverse, it's just going to be this domain. Right, so that's how you can do it if you don't do the graph, which is what we're going to try on example 5. Okay, so f is an invertible function from when x is from -2 to 8, and we're going to answer some questions about the inverse of f. And so we want to find the maximum value of the inverse. What I would do, if I just want to use f, is find the maximum of the domain of f. So what is that going to be? 8. So the maximum of the domain of f is going to be the maximum of the range of f inverse. All right, and then f inverse of 3, I will just go on the y, when y is 3, on the function x is 2. And then f inverse of 1 means we want to find what x value makes the y 1, which is 3. All right, and then this last one, we want to find the domain of f inverse. What should it match up with from f? The range. So we'll just do the range. The lowest y value, the lowest y value is -3. The highest is 7. Now, if you go to do these problems like on the test and you get really confused, you can always draw the inverse graph if you want to, and then answer questions using it. Okay, so one more. We are going to do a combination of graphical and numerical to do some just regular compositions and do some compositions that involve inverses. So sometimes it's hard to go back and forth, so we're going to practice that. So it does tell you that h is an increasing function, so it is invertible. All right, so g of h of 6, that's old stuff. G of h of 6 means we're just going to start with h of 6, regular old, go to h, find the value of h when x is 6. That's just going to be 10. Right? Same thing here. G of 10 just means go to the graph of g. When x is 10, what is the value of the function? It's just -1. So that's old stuff from before today. All right. B has some old stuff and some new stuff. So we're going to do g inverse of h of 0. H of 0, just regular old. Go to the h function. When x is 0, the function is equal to 3. Right, and then g inverse of 3 is new. That means we want to find what x is going to make this function equal to 3. So we go to the y of 3, and that's just going to be 4. All right, so you guys try C and D on your own if you haven't already. All right, what questions do you guys have?